In example 5.1e, we have the equation y equals the square root of x minus 3. Now, the x minus 3 by itself has no issues. I can take any number I want and subtract 3 from it. No problem. But once I figure out what that number is, once I take 3 away from some number, I then have to take the square root of that. If that number is negative, then I can't take the square root of it. So we have to be very careful about the square root here. And what we've said in the past is if we don't want negatives, then we can force it to be all the other stuff by making this be greater than or equal to 0. So when we say greater than or equal to 0, this means non-negative. So 0 would be considered non-negative, and then anything positive is also considered non-negative. So all that is included in there with the greater than or equal to 0. So I'm going to take x minus 3, have it be greater than or equal to 0, which is then going to get me the statement x is greater than or equal to 3. And that gives us an algebraic calculation for the largest possible domain to go along with this equation. So we'll define our function as f. The domain will be coming directly from what we calculated. It will be 3 to infinity, including 3. This is what's going to map to other real numbers given by f of x equals the square root of x minus 3.